Alright, so these first four problems are all about converting back and forth between particles and moles. And particles can be a whole bunch of different things. They can be atoms, they can be molecules, they can be formula units or ions. Although those are probably the four most common in chemistry, right? They could be anything. They could be puppies, they could be pieces of cheese. Right, a mole is just a counting number, and a mole is equal to 6.02 times 10 to the 23rd things. This number is called Avogadro's number, and we can use it as a conversion factor to go back and forth between moles and particles. The tricky part is figuring out how to use it and how to arrange your conversion factor, this 6.02 times 10 to the 23rd things per mole, to give you the correct answer. So when you're going from moles to atoms, or moles to molecules, or moles to any sort of particle, you're going to want to multiply by Avogadro's number. Because when you do so, like in 90A and 91A, your moles will cancel out, and you'll be left with the final answer that you want in the units that you want. So that's the story with 90A and 91A here. Multiply your number of moles by Avogadro's number, your moles will cancel out, and you'll end up with your final answer. In number 93A and number 95A, we're working in the opposite direction now. So instead of going from moles to particles, you're going from particles to moles. So now instead of multiplying by Avogadro's number, you're going to want to divide by Avogadro's number. Doing so, right, you'll cancel out the units you want to cancel out, and you'll be left with the units that you want in the end. Right? You'll be left with moles. Remember, there are many things per mole. There aren't many moles per thing. So if you're going from atoms to moles or molecules to moles, your final number should be a lot smaller than your initial number. Number 108A is all about molar mass. And molar mass is another type of conversion factor that allows us to convert between grams and moles. Right, you can find the molar mass for the different elements on the periodic table, where the number is located underneath each element's symbol. So in the case of helium, the molar mass of helium is 4.003 grams per moles. Molar mass allows us, as I said, to convert between grams and moles. The tricky part is figuring out how to arrange it, figuring out if you need to divide by molar mass or multiply by molar mass. And the key is knowing what units you want to cancel out, so using this as a conversion factor, just like we did with Avogadro's number, except for we use it in different circumstances. So when you're going from moles to grams, you multiply by molar mass. Doing so will allow you to cancel out your moles and leave you with grams. So moles to mass, you multiply by molar mass. In problems like 112A, we're putting it all together. We've got two conversion factors now. We've got molar mass. So molar mass allows us to go between grams and moles. It's molar mass. And Avogadro's number, which allows us to go between moles and particles. We abbreviate Avogadro's number, capital N subscript A. We've got two conversion factors. So in number 112A, you're starting with a number of atoms, and you want to go from atoms to grams. We don't have anything that can directly take us from atoms to grams, so you've got to do it in two steps. In the first step here, right, we're going to go from atoms to moles, because once we get in moles, we can go to grams. In order to do that, we're going to divide by Avogadro's number, and our atoms cancel out. The next step from here is to use molar mass to get us to grams. In this case, we multiply by the molar mass of uranium, which is 238.029 grams per mole. Our moles cancel out, and we are left with grams, which is what we want here. So that gives us our final answer, 1.67 times 10 to the negative 6 grams. In number 113A, we're working in the opposite direction. So in this case, we're starting with grams, and we want to end up with particles. In this case, the particle we're talking about is atoms. So we use our molar mass to get us from grams to moles. We divide by molar mass now because we want to cancel out grams and get moles. Once we're in moles, we can then go from moles to atoms. When you go from moles to atoms, you multiply by Avogadro's number. That allows you to cancel out your moles and end up with atoms. So the final answer to this one is 7.74 times 10 to the 22nd atoms. Number 116 is just like number 113A, except for you're calculating the number of atoms of sulfur and of vanadium separately. So in this one, you're told that a compound contains 3.86 grams of sulfur and 4.08 grams of vanadium. You want to figure out the atoms of each of these things. So we do the same procedure we just did in 113A. You divide by molar mass to cancel out your grams, and then you multiply by Avogadro's number to cancel out your moles. Or you could do this in two steps. You could figure out how many moles you have first of all, and then multiply it by Avogadro's number. I just did it in one long sort of equation to be quicker, but it's perfectly fine if you want to break it up, and, so you can keep track of your work a little bit easier that way. Okay, we do the same thing with our vanadium. We start off with 4.08 grams, multiply by molar mass to cancel out grams, and then multiply by Avogadro's number to cancel out moles. If you play your cards right, if you keep track of your conversion factors and know what you need to cancel out, you should end up with the right answer here.